Hello everyone. So in this video, let us see the important interview program so called TwoSum, which is from easy level. So first, let us see the problem statement, and afterwards, let us see the example explanation, and so finally, let us see the implementation so part. Okay. So given an array of integers so called nums here and an integer target. Okay. So already so to the so called method array values are next of all target passed here. So array variable when there is nums given and some value target is passed. Okay. And return indices of two numbers such that they add up to the target. Okay. On adding, so which two values you'll get the so same result, same value as target we should find here. Okay. So that is a problem statement here, and you may assume that each input would have exactly one solution, and you may not use the same element twice. Okay, so might be duplicate elements may have in the so examples. Okay, in which case in that scenario, by adding so the same element twice also you'll get the so target. We should not use that. Okay, you can return the answer in any order here. So order is not important. And next. So let us take so the first example. Okay, so here I'm adding 0 on first position values, you'll get the target. Okay, we need to return those positions here. So here first input is in sorted form, but the next input is not sorted. Okay, you can check that. So if input array is in sorted form directly, so the better approach, optimal approach for design solution is two-pointer approach. But here, so the array is not sorted. Which approach we should prefer? So all this let us discuss detail on that. Observe the constraints here. So that is length of an array lies in between so 2 to 10 power 4 and array values both negative and positive you can observe. Okay, target also you can observe both positive and negative values. Observe the follow-up also here. Can you come up with an algorithm that is less than order of n square time complexity? Okay. So first of all, I'll explain so the brute force approach, which is order of n square time complexity one. Afterwards, I'll reduce that one to the order of n time complexity so n to n log n, that is hashing approach we are going to prefer. Same thing you can found in the topics also here. We need to prefer the hash table. And so if you are designing so the any program, you can if you cannot design, you can go through so these hints after completion of the program. So go through the try to solve the similar questions. Okay. So don't forget solve this. So now let us quickly move on to the example explanation. So here, okay. Let us take so the first example only. It's the best one. 2, 7, 11, 15. So the target is 9. So these are, sorry, it's array values are here. Okay. So the first thing is brute force approach. Okay. Straightforward. So for everyone, so brute force solution strikes. Okay. So I'll explain so that one. Okay. That is, let us take some other target value called something called 70. Okay. So for clearly understanding. So we need to fix one position and so the remaining position values and adding that fixed position values, whether we'll get the target or not, we need to check like this. Okay. So for fixing one position, so we need one loop here. And next of all, so for generating remaining positions, we need another loop here. So that is J I'm taking. So first, let us take so 2 plus 7 result is 9, not matching with the target that is 17. Okay, the scenario J loop updates to the next location here. So that is 2 and 11 now. So we need to add 2 and 11 on adding, so it becomes 13. Once again, not matching with the 17. And again, so J updates to the next location. So 2 plus 15, it's 17. Matching with the 17. Now in that scenario, we need to return so those positions here. So that is 0 and so 3. Okay. So here it's ended with the one iteration. So for if suppose if you take like this means so 18, okay. So here what will get 17, which is not matching with the 18. So what happens? The I loop changes to the first position. J, we need to start from the next position because next position of I, because already we checked so the 2 and 7 values. Again, on starting the J from the 0 position again and again, there is no use of it. We are reducing some iterations here, okay? 7 and 11 on adding, so it becomes 18, which is matching with the 18, and we need to return so the first and second positions here. Okay, this is a brute force solution. So let us go for implementing. So this one. So let us see what happens. So there is already some to sum method is given here. So array variable nums and next of all target is given. We need to return some list of integers. Okay. Now we need to generate some so range of values here, right? Okay, all values. So first of all, I am collecting the size of array here with the help of length function, length of nums, and next of all, I'm generating so the I position values here. So with this loop, next of all, what I said, J loop, we should start from the next position of so I, right? Okay, I plus one, so comma n, and next to this, so I and J position values addition result, we should check whether matching with the target or not. Okay, if matches, we need to return so I comma J position values. Okay, let us run and submit and check whether it works or not. It's base test case executed here. Let us submit now. See how much time it's taking. So 1673 milliseconds. Okay, it's very huge, right? Yes, all test cases passed here. So, but you can check it's taking so the more runtime because means the time complexity of this program is huge. Okay, so means might be everyone know about how to take time complexity of this one. So that is if you take size of an array as 4, okay. So for each and every I value, we should check how many times so the J loop iterates here, okay. So for I value 0, J loop iterates for 3 times. For I value 1, J loop iterates for 2, and finally 1. Means if you take size of array as 10, so J loop starts like this, okay, 9, 8, 7 like this, it executes up to 1. In mathematics, we can write this one as like this, n minus 1, n minus 2, and so on up to 1. So if you found this series, you can take so the NC2 formula, that is n into n minus 1 divided by 2 on segregating, so this one deducting, you'll get n square minus n divided by 2. In this one, the highest degree is n square, which is the time complexity of this program. N square it is, okay. So now our task is to reduce the time complexity of this one, okay. So that one you can so do with the hashing here. So with the help of hashing approach, so you can reduce the complexity of the solution, okay. Let's see how to implement it. I'll explain with the picture here. So first of all, we need to take so the dictionary here. So I'm taking so the empty dictionary. Okay. Next of all, we need to generate so the each and every position value here. Okay. So how we need to design it? Let us check now. Okay. Let us take the same values 2, 7, 11, 15. So observe everyone. Let us take target as 9 and array values as 2, 7, 11, and 15. Okay. So the first step is here. So we have target with us, right? And some array values. So what I said, let us generate position values. So with the loop here, so first of all, what is the first position value? It's zero position value 2, right? Okay. So we have target with us and some position value. We should check whether, so it's simple mathematics here. So target on subtracting, so with the I position value, so you'll get the some result. Okay. So means observe this. We are at zero position now. Okay. And adding some position value, it should get the result 9, right? So means we can check like this. So 9 on subtracting with 2, so what is the result we are going to get? Okay, means in this place, so we should have some 7, right? So with the help of 7, so you'll get the target result here. But first of all, let us check whether that 7 value is present in the dictionary or not. Okay, it is not present in the dictionary, right? So in that scenario, we need to add it into the dictionary. So that position value means zero position value, and so that particular index we need to add it into the dictionary. You know, dictionary is in the form of key value pairs, right? So what I'm doing here, so in the key position, I'm taking so the array position value, and so for value, I'm taking so the positions here. Okay, so we need to repeat the same thing here. So what is the next I position value? Okay, so 7, right? Now, so I position value it's 7, and next of all, so we need to get the target 9, right? So now I'm subtracting target and so the current position value. So what you'll get? So the result is 2. So now check whether this result 2 is present in the dictionary or not. No, yes, it is present now. Okay. In that scenario, what you need to do now? So the current I position value, and so whatever the value attached to this key, we need to return. Okay. What is the value attached to this key here? That is 0. And what is the I position value? It's 1. Okay. So these two we need to return here. That is 0 comma 1. Okay. I hope so. You understood. This is the way of designing. So the program with a hash table, that is a dictionary in Python here. Simply target, we need to subtract with the each and every position value. Okay, and later on we should check whether that key is present in the dictionary or not. Okay, so if not present, we should go for adding so that particular key value pair into the dictionary. For suppose on subtracting target and some current position value, if you found that key in the dictionary, in that scenario, we need to return the value whatever attached for that and that current position value. Okay, so this is the implementation part here. So observe everyone. Let us reset this first of all and observe. First of all, I'm taking an empty dictionary here. Next of all, I'm generating range of values from an array. Next, let us calculate the difference. First of all, what I said. So target we should subtract with the current position of array, right? So if you found the difference in the dictionary, what you need to do, let us see later. But in the initial iteration, you observed that so we don't have anything, right? Dictionary is empty. What happens? It goes for executing outside of if statement. So that is what I said. If you do not found that particular difference in the dictionary, to the dictionary, we should add that particular array position value as key, and next of all position as value. Array position value I am adding as key, and position I am adding as value here. Okay, And so in the next iteration, so what we got, we taken this example, right? That is 2, 7, 11, 15. Okay. So initially, target we taken 9, right? 9 minus 2, it's 7. It's not present, right? What happened initially? So to the dictionary, so 2 value and next of all 0 we added. Initially, so 2 comma 0 we added into the dictionary. Next of all, in the next iteration, so target is 9. What is the next position value here? It's 7, right? 9 minus 7. What is the result? 2 now. Now this difference 2 is present in the dictionary here. Yes. So what we need to return then? Observe return dictionary of, so D of, so this 2 value we are getting into the difference variable, right? Okay. With the help of so difference, with the help of D of difference means D of 2. So we can retrieve so this, and next of all we can return so the current position value. This one we should return in the form of an array. So D of difference and next of all I position values returning. So here let us test and so submit now. As base test case executed and next of all so submission. Yes, now check how much time it's taking. 0 milliseconds. Okay, all test cases accepted here. 100% it's beating solution. Okay, so this is the best one, best time complexity programs when compared to the previous one brute force approach. Okay, I hope so each and everyone so clearly understood so this one. Okay, so that's it. Thank you everyone.